Let's start electron affinity. So today we are going to discuss electron affinity. Okay. Electron affinity means that attraction towards electron. Basically, when something gains electron, let's suppose this is X in the form of gas. When it gains one electron, so it forms this. Okay, this is what? This is electron affinity. And this is electron affinity, right? So basically, what is standard electron affinity? What is standard electron affinity? As we have discussed the lattice energy, we always discuss different condition under standard conditions. Like I told you, 250, like you can say 1 atmospheric pressure and 25 degrees Celsius, right? So basically, we would be discussing this under standard condition. But what is electron affinity? But the thing is, what is electron affinity basically? So um, electron affinity means that like the proper definition of electron affinity, that when 1 mole of gaseous atom gains 1 mole of electron, to form 1 mole of -1 anion, or you can say that 1 mole of anion having -1 charge. Okay, so I told you that electron affinity is of both. It may be exothermic and it may be endothermic. I told you. I told you in the next class. It may be exothermic, it may be endothermic. So remember, if I talk about oxygen, this is gas. This is gas. It's going to gain electron. Would be forming this first electron affinity, which is exothermic. You know, oxygen is going to have -2 charge. After gaining one more electron, it would be forming O2 minus. This is second electron affinity. That is endothermic. Can anyone explain why the first electron affinity is exothermic and the second electron affinity is endothermic? Yes? Hmm?
Maybe because the second electron
Hmm?
is like it needs more energy to be removed.
Yes, Sahil, what do you think? Subhan, what do you think? Why the second electron affinity is endothermic? Yes, Faisal, क्या बोलते हो तुम? Hmm? I'm waiting for your answer. No idea? No idea? Yes, Hasib. What do you think, Hasib? No idea? Yes?
Sir, can I tell? Subhan.
Yes, Subhan.
Sir, I think that when we add one more electron, we need more energy.
Oh, I'm telling you that वो होता ही second electron affinity is more endothermic. Like it releases, it absorbs energy. It absorbs energy. Okay, let me tell you. When you were having, let's suppose when oxygen were gaining one electron, at that time it was neutral. At that time it was neutral. There is no repulsion between them.
Sir, it is due
So
to the
it can
additional
easily
energy.
gain electron. It would be released. It would be releasing energy. Exactly. So when it's going to gain, it's the second electron. Right now, oxygen is having -1 charge, and electron is also having negative charge. So when O minus is going to gain electrons, so they would be repelling each other because they have the same charges. They would be repelling each other because they have the same charges, right? They would be repelling each other, but oxygen has to gain second electron because oxygen has -2 charge. Generally, the charge of oxygen is -2. It has to gain second electron. So, in order to overcome the force of repulsion, in order to overcome the force of repulsion, okay, in order to overcome the force of repulsion, you have to provide energy. You have to provide energy. So that's why we say that second electron affinity is endothermic. So to overcome force of repulsion, okay, second electron affinity is endothermic, right? Yes. Okay. Then what are the factors? Then what are the factors of electron affinity? Then what are the factors of electronegativity? Okay. What are the factors of electron affinity? So see, let's suppose this is fluorine and this is chlorine. It's 9 and it's 17. Both are in group 17. This is my question. Which is going to gain electron first? Fluorine or chlorine? What do you think? Which is going to gain electron first? Yes? Anyone?
It's fluorine.
This. Why? Why?
Sir,
Can
I
you
said
repeat?
Yes. Mhm.
Sir, can you repeat your question, please, once more?
Basically, you have to look at the size. Basically, you have to look at the size. Okay. Like if you can see the size of chlorine, so chlorine is in third period. What does it mean? It means that chlorine has 3 shells and fluorine is in second period. So fluorine has 2 shells. So more shells means larger atomic size. Larger atomic size means it has a lower attraction towards electron. This is chlorine. This is the nucleus of fluorine and this is fluorine. This is the nucleus of fluorine. This is electron. This is electron. So weak attraction. A strong attraction. Are you getting my point? Yes or no? Yes?
Yes, sir.
Okay. So means that it depends on the number of shells. Number two, okay, it depends on the nuclear charge. It depends on the nuclear charge. Like let's suppose, uh, let's suppose nuclear charge means that the nuclear attraction. So it's having greater nuclear attraction. It's having a greater nuclear attraction. A strong nuclear attraction. A strong nuclear attraction. And it's having a weak nuclear attraction. Okay. And also, why it's having a weak nuclear attraction? So you will say it has more shells. You will say it has more shells. It has a greater atomic size. It has a lower attraction towards electron. So if I say I'm going down the group. I'm going down the group like fluorine, chlorine, bromine, iodine, astatine. Can anyone tell me if I'm going down the group? So electron affinity is going to increase or decrease? Yes. It's going to increase or decrease?
Decrease.
Yes. Exactly. This
Decrease.
is decrease. Yes, this is decrease. Decrease because ability to gain electron decreases. Because ability to gain electron decreases. Ability to gain electron decreases as the size increases. So the attraction towards electron decreases. So I can say that the electron affinity is going to decrease. That's it. So these are the factors on which electron affinity depends. So the examiner would be giving you the different elements and would be asking. So you have to just consider these things. So it's quite easier for you to draw the electronic structure first, then you can decide easily. Then you can decide easily, okay, that which element is going to gain electron first or not. Is that clear? Okay, should I go ahead? Hasib and Subhan, are you getting my point clearly? Yes or no?
Yes, sir.
Yes.
Good. Faisal, किधर हो आज तुम? You're silent. Silent killer.
Sir,
Hey, Faisal.
the graph which that is decreasing, it is about halogens, right?
Yes, this is halogens. And generally, non-metal gains electron. Remember, electron affinity is the term which is used for the non-metals, specifically for non-metals. Specifically for non-metals. Okay. Okay. Then we have how to draw the Born-Haber cycle. How to draw the Born-Haber cycle, basically. Now let me tell you this. Okay. So I'm going to draw this Born-Haber cycle for sodium chloride. Yes. This is sodium solid. This is chlorine gas. This is sodium chloride solid. This is sodium chloride solid, okay? The name of the process is enthalpy change of formation. I'm supposed to put half over here to balance this equation because this is one chlorine and the standard form of chlorine is Cl2 gas. So I need to put half over here to balance this chlorine, right? To balance this chlorine. I need to put half over here to balance this chlorine. Now this is balanced equation and this process is known as enthalpy change of formation. What was the definition of enthalpy change of formation? When 1 mole of a compound is formed, when 1 mole of a compound is formed from their elements in their standard states. The standard state for sodium is solid, and the standard state for chlorine is a gas, and chlorine is diatomic gas, right? This is called enthalpy change of formation. Enthalpy change of formation. Yes, now see this. Now see this. First of all, I would be converting this sodium solid into the sodium gas. Can you tell me the name of the process? Yes. Can you tell me the name of the process?
Atomization.
Atomization. This is enthalpy change of atomization. Sahil, Sahil, why this is atomization? Sahil, जल्दी बताओ. Hmm?
It goes from solid to gas.
Exactly. Exactly. चलो जी, आइए जरा आगे. So now I'm going to convert the sodium gas into the Na plus gas. Yes, Subhan, can you tell me the name of this process? Yes, Subhan. Subhan, fast. जल्दी
Sir,
बताओ.
which process? From sodium
This,
to?
what is this? What is
Mm,
this?
Sir, this is also atomization.
No,
No, sir.
Faisal.
No, sir, no change.
Ionization.
Ionization. This is ionization because gas to ion, cation. This is ionization. Enthalpy change of ionization. Okay, from gas to cation. From gas to cation. This is ionization. Okay, then I need to convert. Then I need to convert this chlorine into this. Can you tell me the name of the process? Hmm?
Atomization.
Exactly. Again, this is atomization. Because molecule to atom. Because this is again molecule to atom, right? Why I'm going to make upward arrows? Because the process is endothermic. When the process is exothermic, we are supposed to write down the arrows downward, right? Now, if you can see this, yes, can you tell me the name of the process?
Electron affinity.
Yes, we have discussed right now. This is electron affinity. Gas to anion. Gas to anion. Then they would be reacting together to form sodium chloride. And this is known as the lattice energy. This is the complete Born-Haber cycle. This is direct route. Okay, this is direct route, and this is indirect route. Just like a Hess's law. Just like a Hess's law. The same thing. The same thing. Just like a Hess's law. The same thing. Okay. Considering this, keeping in mind that you are supposed to draw the Born-Haber cycle of magnesium chloride, but fast. Fast. You are supposed to match. I'm just drawing, okay? I'm not saying something. Just see this. फैसल समझ आया? फैसल, is that okay? हसीब, okay. This is bit difficult, okay? Just try this. Okay, see this. I'm going to draw this. Just you have to cross check. Just you have to cross check, okay? See this. This is enthalpy change of formation. This is 3/2 to balance this equation. Then this is gas +1 +2 +3 okay. This is and we have this, okay. So this is what, this is what, this is what, this is what, this is atomization, this is ionization first, second, third, atomization, then first of all O minus. As you know that the second electron affinity is endothermic, so I'm going to go upward because upward arrow means endothermic. Then this is the lattice energy. Then this is the lattice energy. Okay. This is second electron affinity. This was the first electron affinity. Okay. This is quite tricky Born-Haber cycle, right? Okay. Are you getting my point? Yes, that clear? Faisal,
Sir,
Sahil, so yes, Tala.
so the upward arrows are endothermic.
Exactly.
Okay.
फैसल समझ आ रहा है? सुभान, साहिल, is that okay? सुभान,
समझ
सुभान समझ आ रहा है? नहीं आ रहा है?
आ रहा है जी सर आ रहा है समझ
गुड हो गया, गुड हो गया, गुड हो गया. Okay. So this is, and also the same goes with magnesium nitride. This is the recent question. Magnesium nitride. Magnesium